Okay, so we're going to look at one of these problems of calculating molar concentrations or number of ions given pH. And we said in the last problem that really the issue is just that the pH is measuring number of proton ions. Okay, so we said pH is a measure of proton ion molar concentration. Okay? And so molar concentration is all we've been talking about. So this question is saying we have a certain number of ions and we know the volume, and now we want to calculate the molar concentration. So this is kind of the opposite of the question number 3 that we saw previously, but is a similar type of problem as we've been talking about. Okay, so let's look at what we have. In general, most of the questions that you'll have here are going to be some multiple of number of moles. So when you look at this question, what you want to do is say, how many moles is this? And so rather than doing it, so what you can do is you can say that I can take 12 times 10 to the 17th and divide that by Avogadro's number. And that's saying the same thing, but really you can look at, this will give you the answer, but it's slow. So the other way you could do this is I can look at this and I can say, okay, this, if I know that Avogadro's number is 6 times 10 to the 23rd, if I look at this, this is 2 times that, okay? So let's start with a 2 times, and then let's look at the factor right here. 10 to the 17th is 10 to the minus 6 times Avogadro's number, 10 to the 23rd, okay? So this is a power of 6 down. And so one interesting way to think about that is, you know that 10 to the minus 6 is a micro, right? So it's micro, this is now in moles. So let's write that, moles. So that's the total number of ions that you have written in moles, okay? So we just converted from number of things to number of moles that you have. So an interesting way to remember this is if I say, if I have, let's start with Avogadro's number. 1 milli down from that is 10 to the 20th. That's a milli. Okay? That's 1/1000th, right? Because you're going down 3 orders of magnitude. A micro, which is that Greek mu, it's written with a funny mu, is 10 to the 17th. It's a micromole. It's 10 to the 17th. 6 times 10 to the 17th. 10 to the, yeah, 17th. Nano is 10 to the 14th. Okay, so this is a really quick way to basically say, okay, if I know this is micromoles, then this is going to be 10 to the 14th. Or if this is micromoles, it's 10 to the 17th. And so I don't have to do all the thinking. Or you could subtract if you want. Okay, but this is 10 to the 17th. And so we'd write, we could also write this as, and I like to do this, 2 micromoles, or the mu symbol. Okay? Now we're almost there. We said that we wanted to know what's the pH. So you have this. This is actually in. If you look at the question, we need to get molar concentration. This is in micromoles. So we need to divide by the volume, because concentration is number of things divided by volume. So we're going to divide that by 2 liters. Okay, and so our volume, our concentration is 2 micromoles divided by 2 liters, which is 2 micromolar concentration. I'm sorry, 1 micromolar concentration. Okay, we're almost there. So 1 micromolar concentration. Now we say, okay, what does that mean in terms of concentration? So we said the definition up here. pH is the log base 10. pH is log base 10 of the protons. And so that means that, as we said before, if you have a pH of 3, that corresponds to a concentration of 10 to the minus 3 molar. Remember what I said now, we've got 10 to the minus 6 molar concentration in micromolar. Okay, so 10 to the minus 6 molar corresponds to 10 to the minus 6 corresponds to, this is a molar concentration, corresponds to a pH of 6. So the answer is C.